Hey, thank you everybody who hopped on for this month's customer data science group. Again, thank you everybody for joining. It is a crazy time. Hope everyone is staying safe indoors, hence why we're having it online virtually. Very excited to introduce our two speakers today. We have two great chats. As those who've been here before know, the format will be, we'll have two speakers. First one will go, and then we'll have a 10 to 20 minute Q&A. Feel free to ask any questions. We have a Q&A feature at the bottom. You can see, click it and type in all your questions. The speakers can see them and then we'll answer them at the end. But feel free also to use the chat box. I think that's public for everybody to see. But yeah, we'll have our first speaker for about 20 minutes, followed by about 10 minutes Q&A, and then the same thing for the second speaker. Yeah, excited to get going. Again, really exciting speakers. The first speaker today, who's unmuted and has his video on, is Rich.
Hey.
Rich is a software engineer at RStudio, and he works on a number of open source packages that focus on different aspects of data, like reporting, visualizations, and validation. He's currently living in Toronto, and he loves getting outside when not doing data-related stuff. And he and I just had a great chat about playing the bass. So if you play the bass, like going outside, chat with the Rich after this.
I just answered a question about the bass.
But yeah, let me give the floor up to Rich, and thank you so much again for showing up, everybody.
Yeah, okay, so I'm gonna share my screen now. And here we go. Great, okay, great. Oh, sorry, this is for later. Okay, I'm gonna show you the presentation now though. Make this full screen. And so this will mainly be an art talk. One sec, while we get Keynote back on. Okay, great. So this is all about the point blank package. It's a package I've been developing in my spare time. This is not an RStudio joint. This is totally my thing. This package is all about validating data, and it's usually data in data tables. So not like vectors or lists, just data tables. Has tons of functions. A new version just came out like a few days ago. I tweeted about it. I made a blog post. Check it out on Twitter. My coordinates are, I'm on GitHub, Twitter. You can email me. That's totally fine. So a new version just came out. I'll talk to you about one aspect of this package because it's kind of huge, this package, I have to admit. But the whole idea about this package is that you validate your data and you don't have a hard time doing that. If that makes any sense. So let's start with toy data. And because this is the customer data science meetup, I'll end off with a demonstration in the RStudio IDE with actual customer data, just to prove it's real. It's a real package. Okay, so the goals of this package is to enable two big workflows. And so if you have these imperatives, like you really need to understand and get on top of your data quality. Like that's a real thing. You have data, you probably have some data quality issues. Like no data is perfect. Things can happen, joins go bad, software changes that, destroys results, third-party data is bad. You need to understand your data quality. Another workflow, which we actually won't talk about much in this talk at all, is that you need to check your data before it proceeds down a pipeline. So basically your data is transformed during some operations in a pipeline probably. And you should check it before it goes further because it might be wrong. So that's another aspect of this package. Some new secondary workflows, I won't talk about these at all except these little statements right here, is that you can validate your data in unit tests. So our package, most libraries and packages have unit tests. So, and data analysis could have unit tests too. So basically I made a set of functions that work beautifully in unit tests. And another set of functions was added. These are all complementary functions. And they allow you to, get logical values from the tests. And that's great for things like conditional statements. Like, does this data satisfy this condition? Okay, well, they didn't do this. It's part of a programming aspect of it. So in this package, there's a bunch of design considerations, and this is all in the service of the user. It's to make your life easy and to make things difficult for me. So we want you to be able to work with local data tables and also database tables with minimal changes in the API. So there should be no difference in how you type out, how you do the analysis. You point to a table that's either local, like a data frame or a tibble, or it could be a database table. They have as a tibble DBI in R. And also in point blank, we provide some extra tools for understanding your new data. Because before you start creating validation rules, you should really just have a first look at it and just understand the lay of the land when it comes to your data. A big thing also I have is reporting outputs translate to multiple spoken languages. So far we have English, French, German, Italian, and Spanish. I hope to add more, but it's kind of difficult because this has to be correct. And English is my main language. Another thing is to focus lots of attention and time on making the docs and examples best to be, because if the example is hard to use, if the package is hard to use, most people won't bother unless there's lots of good examples, good documentation. Okay, so I'll talk about the point blank data quality workflow. It's basically understanding how good your data is. You start off with an agent, and I made icons for all the functions in the package because I had lots of spare time. And an agent is an integral part of the data quality workflow. It's kind of like the reporter. It does things for you. It's the thing that carries the whole process along. And then what you give the agent is a target table, and that's the table that'll be checked for its data quality. So you just give it to the agent. Then you give some directives on the interrogation. So these are things that we won't really talk about. But essentially, the actions are things like, what are thresholds for quality? End functions is, what do you do with all the, so you did your data analysis. What do you do with it all? Is there some side effect that you can do? Like maybe send an email or do some logging. And lang is language, so 5 reporting languages. Great. So the next step is to use functions. And these are functions that are used to generate a validation plan. So we have things like comparison functions. We have things like whether data is in a range or outside of a range, whether it's in a set or not, whether data is duplicated, whether there's null or non-null values, whether it satisfies a regex, or whether certain columns have a certain type. So things like that. And even the column schema, we can check that as well. So we have all these functions that we can make validation steps with. And then after that, we look at the data. We actually interrogate the data. So we have a plan, and now we carry out that plan. And once you have that carried out, like the data is all interrogated, you have tons of intel. And what you do with that is you could do lots of things. You could use these post-interrogation functions for reporting, get a report out, of what happened. You get data extracts, so each step you can get the failing rows, see what's going on, why did these things fail. Sundered data, that essentially is data that's split into the passing rows and the failing rows. You may want to look at this entire collection of failed rows, or you may just want to filter your data to get the good stuff. And the X list is its giant list of everything that went on, and that can be useful for programming. Okay, and another thing you can do, and I'll show this to you later, is you can scan the data, and that's basically a report that's generated just showing you your data, one column at a time, giving you essentially all the stats you need to see if there's anything really weird happening. Okay, and yeah, if data quality isn't all that good, you could send this, this report that you get out as an email, and you can do as much or as little as possible. It's up to you. Okay, we're going to start with a simple table, so I can show you validation rules and how they work. And so we're going to start with this 5 rows, 3 columns, super tiny table. And these are this is my plan. So I have 5 steps, and I'm just going to read these out. All values in C, this column, should be greater than 15. That's one of my rules. All values in B, this one right here, should be either 0 or 1. We already see that's not quite right. Step 3, all values in A should fit a pattern of 3 lowercase letters and a digit. That looks kind of right. Here's a complicated one. Values in C must be greater than 20 if B is 1, and if B is 0, then values in C must be less than 20. That's a pretty complicated statement, but we can do that. And columns A, B, and C should not have any missing values. And if you don't notice, in R, NA is a missing value. It's like null in databases. Okay, and we have functions for this. We have, so these are all call vals functions. So what they do is they check every cell in every row of a target column. And then we have, the different endings, like greater than or equal to, column values in a set, column values fitting regex. This is using expression, sort of a DIY approach to doing a validation, and then using the case when statement, which is basically what we have right here. It's 2 cases. And another one here, column values are not null. So this is kind of how it looks like in R. You give it the target column right here, and you give it the rules, the comparisons. So C should be greater than or equal than 15, column values in a set of 0 and 1. It's pretty cool. So once we have this, we're going to interrogate the table. So it comes back. So I'm going to show you how the interrogation works and some terminology there. Okay, so for the first step, column value is greater than or equal to 1. We split things down to test units. And this is important to really break it down to units, because that way we can determine how many units passed or failed and see if it broke through a threshold, which is an acceptable, quality threshold. So as we go down, we see that, like this one's missing, so that doesn't pass validation. And just so you know, there's actually a parameter we can say NA pass, and you can let these NA values pass if you really want that. And it generates, we got a little report of 4 passing units, 1 failing. This is the fraction. I'm going to go through this pretty fast because it's basically repeating this for every single step. Column values in set 0, 1. We see that the last one does not work, so we have 1 failure. Fitting a regex, let's have a look and see how that works. The second last one did not work because it's not 3 letters. It's actually just 2 letters and 2 digits. And we have an NA, which definitely does not pass in this case. Okay, here's a case 1 statement. It involves cases of b equal to 1 and b equal to 0. It only involves like 4 test units because this case is actually disregarded. And they all pass, so yay. Okay, column value is not null for columns A, B, and C. This is actually 3 steps in 1. It splits it out for you. It's very nice that way. So basically, this is just going to be checking whether there's null values. And of course, there's 1 there. There's none here. And there is exactly 1 here. So we have a bunch of reports. And here we are. They all come together in different steps. It's kind of nice. This is part of the report. But for even better reporting, we could set thresholds and use side effects if we want to. So failure thresholds can be set for 3 states: warning, stop, notify. This is kind of like logging. And so we can set W, which is warning, to trip if the threshold's 1 failing unit and stop for 2 failing units. It's a very small data set, so we're setting this very low. And you can also use fractions of failing data. It could be 0.1 or 0.2, that sort of thing. And if we apply these, we see that we get a table out, and it's quite nice. So we get 2 steps. This is not the same data. I'm just showing an example of the validation report. But it looks kind of like this. This is an HTML table, and you can do all sorts of cool things like get a CSV of failing rows. If you just see this on a web page that you may post on an internal work website, you can actually look at these things and hover over different elements and see what the validation is all about, whether it generally went well or not, and you might even have access to more data. Basically, this is great for things like data engineering to get at the root cause. And yeah, so after you have the interrogation done, you can use different functions to do different things. So we saw getting the agent report, which is this. We can get data extracts. Basically, in our analysis, step 1 didn't fail at all. Steps 2, 3, and 4 did. So we can get the rows that basically did not pass in those steps. Sunder data with this get sunder data function will be kind of like this, but it'll split rows across the entire table. So it'll give you like the good rows and the bad rows, and they're still in the same order, but just sort of shuffled into 2 different sets. And as I mentioned before, this X list right here is just like a huge R list, which gives you like almost every aspect of what happened in the interrogation. So you can do things like roll your own sort of like report if you want to. Yeah, these are my descriptions, passing bill, and agent intel. Okay, so we can do other things too. We can send email or not, depending on the interrogation results. We do that with the email blast function. If you just want to get the email as an object itself, you can use email preview, because you may want to sort of program your email and make it look just right before you instrument it and send it all the time as part of a point blank validation. The other thing you can do is, well, I just wanted to show you the appearance of the email. This is like the stock email. You can, of course, make it whatever you want to do, where you want it to be, because it's made with the Blastula package, so it's good, I guess. But, as it is, this is like the default. But you can change things, remove the footer, change it to what you want, not include the report, just text. It's up to you. You're basically programming with the X list, which is basically everything that happened inside the interrogation. Okay, now I'm going to switch over to a demo, because right now you still don't know that the package is real, because you haven't seen any evidence of that. So here we go. I'm going to RStudio, the IDE, and I'm going to take some data. I've got this Nintendo data. It's not Nintendo, but it's Nintendo, and essentially it's like this this data table that's like from a video game, and it has ads, and you can buy in-app purchases, things like that. So this table is a revenue table. Each line is like a revenue line item. We can see just from this head of data that if it's an ad, we get some revenue from it, very small amount. But if people purchase something, and there's a certain size for that, currency, season pass, whatever, there's a price and then there's a revenue associated with it. Like this is money, baby. So basically, this is important data to make sure we have a handle on it. So the first thing we can do is scan the data, and I'll show you. I did that already. And this is that report where you can understand the data itself, and you can sort of get some information here about the overview of the table. And it's really cool because you can zoom in and see for each column what the type is, some information, and it depends on what it is. Like for price, we can see that it ranged from like 99 cents to 129.99. That's the maximum price for an IEP. And then we can get common values. We see some NA values, which makes total sense. If it's an ad, there's no price associated with it. So this makes sense. This is good. We can use this for the validation stuff. Revenue, that should be a bit less than the actual price because the App Store takes a bit of a cut. But oh no, look at this. The maximum is higher than this price. So something's wrong. We already see that something's really wrong here. And max and min values are a great way to check if things really out of whack because it shows the extremes of your data. And we see some interactions. Essentially, this is like comparing numeric variables with each other and even categoricals together. We see we have ad. Oh no, look at this. This is ad spelled wrong. We have another problem in our data. Okay, we can check this up with point blank. Okay, but already we were seeing already that we have got some problems with our data. And this is for checking out missing values. Of course, size and price have missing values. Everything in blue means there's no nulls in our data. Okay, very cool. So we're going to do a point blank data quality analysis. And here are the Nintendo products. This is just a vector of things that I know exist in that one column type. This is a column schema. So basically, I'm saying that this table has this structure. It has these columns, and they're of these types in R. And we can do this for databases as well. You just put in the DB SQL types, and it works just the same. But you have to choose, and you have to have a DB in the first place to make that work. And then action levels. This whole thing is setting thresholds. So we're going to warn when we have 1% of the data failing, and we're actually going to stop when we have 10% of the data. We're not actually stopping, but that's just kind of like the failure condition. Okay, so the first thing we do is create an agent. Then we use these call vals functions, or they don't always start with call vals, but essentially these validation functions, and we have a bunch of them here. And we're going to test things like, whether the dates are between these dates here, whether the revenue is less than the price, and it should be. And we suspect that's actually wrong. So we're going to actually catch that. And then the column values of type should be in this set: add, currency, season pass, offer agent. Everybody knows there's been a misspelling, so we got some bad data. It's ADD instead of just AD. Okay, so there's a few more things. I'm just going to run this whole thing right here, and we'll show you this to you in action. Let me just get all these things loaded up, assigned. Okay, I'm going to expand this a bit so you can see what's going on when you run this. So when you interrogate, when you're in interactive mode, it shows you each step, and it sort of gives you a preview that things are good or bad. It's not bad. I mean, this is a 2 million row data set. Not that big, but it's doing some stuff like regex and other stuff like that. So it's a bit slow on some steps. So yeah, we did that. Now we can check out the actual report. I'll expand this now. So just typing out agent, where we assign it to, prints it out. And this is cool. We can get CSVs of the failing rows. And this is the part where we saw like, the revenue was actually higher than the price. Let's actually take a look. We'll get like a slice of this data that failed. And it's going to by default open up in Apple numbers. But here we go. We see the revenue here is above the price, which is kind of an impossibility because the revenue should always be less than, like the net should be less than the gross. So there's some funky data in here, and we caught most of it. So root cause, we found some bad data. Maybe we can fix it. Same thing with this in set. It should be, if you hover over, we see the entire set right here. We just have to be in focus right there. So let's take a look at that CSV. And the CSV is not the only way to go. We can use other functions like get data extracts. Now we'll show you that, but this is just a nice way of doing it if you have nothing else. So here goes that CSV, type add, ADD. Totally wrong, but now we know. Now we know. So yeah, get data extracts. We can get that for step 3. This is where the revenue is higher. Step 4, this is where we have type add. There's more rows. We can control the amount of rows that we sample. There's a limit of 5,000 just because you can easily pull down millions of rows if you're not careful. So there's a limit. Oh yeah, the email. Let's have a preview of how it looks. I guess it takes a second, but it's worth it. It's an HTML email. And it basically generates a report, puts it in here. If you send it through the usual mechanism, which is instrumented up here in create agent as a side effect, it'll go out like this, and it'll go out based on any conditions you specify. For instance, one of these conditions might be you have two validation steps that enter the stop condition. That could be one way to trigger this, or it could just be all the time. It's up to you. So yeah, that's point blank. I'm gonna go back to my title screen, which is at the end here, because I have some information here. You can find more information about point blank at my GitHub. Is here. This presentation is available in my presentations repo. And if you're into R and you're just learning or you want to learn more, I have a book coming out soon. Well, it's actually a NEEP, which means it's almost done. It's like chapters 10 of 13 are done. It's a pretty nice book. It's good for beginners. It's also good as a reference book. It has lots of stuff. You make really good plots, handle data. If you're in the market for a book that's R, do it. And that's it. That's my talk.
Awesome. Thank you so much, Rich. And just to everybody who joined after the presentation started, there's a Q&A function that you can just go ahead and type your question in if you have any questions for Rich about his presentation about the point blank package.
I'm going to try and locate that Q&A part. Oh, I think it's after I stop my share.
No, it's right actually at the bottom of your footer of Zoom.
What? No questions. Come on, ask me stuff.
Well, I have a question actually is, what's the runtime on any of your inspections, and can you run this on big data and produce an email like that for something that's millions of rows, or is this specifically for smaller tables? You
can do it because I've done it before, but in a previous job. I was running it on millions, maybe tens of millions, maybe some rows where they get complete, like all data, close to 100 million rows, pretty wide, like we're talking like 200 columns in some cases. So we've done, it depends, we're running on Redshift, so it depends on how fast your actual DB is and how much memory it has. But yeah, essentially it's just running queries. It's running SQL, but just sending queries. We're doing it in the easiest way possible. In what I mean is we're doing low overhead queries, just trying to get everything. And essentially point blank what it's trying to do is trying to hide all of the, all the translation depending on your back end. You just use these functions, these validation functions. You give it a database, it'll do all these weird hacks to try to get, things are tested. It works nicely in MySQL, Postgres, Redshift, SQLite, local data tables, stuff like that. And so, yeah, it should be as fast as your database. And, if you're doing a SQL query to get the same thing, I'm betting you would probably be around the same for each one.
Awesome, thank you. And it seems like you have a question from Gabe. I don't know if you can.
Yeah.
I can read it.
To build it, okay, yeah. My reason for rationale for building it is because we had data quality issues. I was working in a game company, not Nintendo, but a different game company in Vancouver a while back, and we had so many data quality issues. We had a bunch of games; they had different schemas. We had we had tons of third-party data. Like the ad data coming in was sometimes wrong. We have to, sometimes people were cheating at games and having these outrageous, like scoring values. So we have to catch all these things and, collaborate with our data engineers and try to get at the root cause of what's causing these issues. Try to fix them. Sometimes we had to get back to third parties that, were giving us data segments. And, as soon as we let them know exactly what's happening, things did get fixed. But it's a process. And as we found new things that were wrong with the data, we added new rules and we fixed them, and it just became part of the, the whole process, this whole collaboration between data science and data engineering. So that was the reason. Okay, I've got another question here. For big data, high number of rows and columns, won't the Yeah, it will be, yeah. So basically, it doesn't scale at all. So I cut it off at like 10, and when it comes to databases, which have high numbers of columns, I don't even include that at all because it actually be kind of slow. So it's basically a thing to improve. There's a limit of like 10 things. You don't choose the 10 things. I'm going to have a way, hopefully, to highlight the best 10 sets of columns to compare against. But it's not easy either because sometimes you don't care just about people want to see different types of effects, and it doesn't always work. So it's a thing to improve, but I'm trying to improve that.
Rich, can you talk a little bit of what the Kendall correlation is, since you're the question?
Yeah, certainly. So I'll go back to this. Essentially, it's talking about this right here. We have a bunch of things like correlations. Oh, is it even here? Oh, okay, it's not on this one. Oh yeah, no, I was in the wrong one. Yeah, Kendall right here. It's not even showing it because we actually don't have any data that's has enough numeric data to compare against. So essentially, the correlations between different numeric columns, and what they try to show is that there's a high correlation between pairs of numeric columns. And yeah, this is a thing to improve upon. And basically, these correlations all look kind of the same. So that's not great. So a thing I might work on is try to find a better score to highlight things which are interesting things in the data. But that's for later. So another question is, have you taken a look at Great Expectations? I have, yeah. I started around the same time that I was working on this package, around 2017. Yeah, and what they're trying to do is solve pipeline debt, same sort of thing. They have things like, I think, more support for different backends, lots of different backends. It's not just Pandas. They have, like Spark. And we could do that too in this. I haven't gotten around to testing everything because, essentially I want to validate the package on different backends. And I've gotten as far as like MySQL and Postgres and SQLite. But there's no reason, because we have DBI and it's interfaced to lots of backends and lots of database engines. We could do that as well. So yeah, I have taken a look at pointblank. I mean, at Great Expectations, and they also have the advantage of having more people working on it too. So it's just me on pointblank, and they have like at least half dozen people and tons of community contributors. So I'm the underdog in this one. Okay, any thoughts on making as a QN add-in in the future? What's a QN add? Okay, once I get that, I promise I'll answer that. What is the best workflow to automate this tool? E.g., whenever a file lands in a folder, reading the new data. I did it just through cron before when I was at work. I just ran it every day. You can have different ways to initiate it, but I just had a runner that basically used RScript. I actually used little r, which is, if you search for it, it's like little, like the word and then the letter R. Essentially, it's a way to sort of do R scripts in Bash, and that worked really well. Essentially, it made the HTML artifacts, and essentially it got posted on a web page. And that was a pretty good way of doing it. You can use Connect too. Connect is actually a good way because you can actually use this in Markdown and just deploy it as a publication in Connect, and you get the advantage of having a history, which is handled for you. As soon as I get like some follow-up on QN add-in, I'm guessing they mean add-in here. That would be kind of cool, because one of the things I want to do is help in making these validation rules. So have like validation rules which are kind of set just from scoping it through the data. So a set of stubs really, and that would help to get started. Kind of like templates based on the data. We think that you could do these, have these validation rules, and you adjust them a bit, but it's kind of like a nice way to sort of like get the floor 10 instead of like starting at floor 1, making them all by hand. Oh, and RStudio. Yeah. So yeah, I think I would do that for that purpose, which is basically like an interactive application that looks at your data, sort of combines like this view, and essentially provides some canned rules, which the process thinks would work really well for that data set, and then you can just go from there. So yes.
Awesome. So Rich, you have one more question in the chat, actually sandwiched between two nice compliments for you from Gabe. I don't know if you can see the chat.
Oh, in the actual chat. Let's see here.
Chat, yeah. If
Sorry,
not, I can read it
No,
out.
I got him. So I got very intuitive library. Great thought. Yes. Okay. How long does it take to validate 1 terabyte of sales data Redshift? Oh, I don't know. I'd love to see it. It depends how many validation steps you're doing. 1 terabyte of sales, maybe 20 minutes. For maybe 5 or 6 rules. The whole idea is that you can add as many rules as you want. They just run essentially in serial, and as fast as your database can handle simple queries, you sort of weigh that advantage of using up Redshift time, query time for this, to having a complete sort of coverage of validation. Yeah. I mean, how long does it take to determine whether 1 terabyte of sales is distinct? Has distinct rows in that table? That's probably the upper limit because that's a pretty expensive SQL operation. Yeah, Sparkly R, I think so. Haven't tested it. It's essentially it's a dplyr backend, so it should work. Especially since dplyr, we're using dplyr internally. So I didn't invent translation here. Essentially, it's making SQL. I try to keep it as simple as possible so it work on different different backends. And as long as it's ANSI, and I think Spark had that for quite a long time, or maybe it just started with that today. But I think it's possible, and maybe I'll fire up my Databricks Community Edition and really give this a test, get some temp tables up, and see what's going on in Spark 3.
Awesome. So Rich, I think if anyone has one last question or so, we can probably squeeze it in, but that's getting close to our allotted time. So speak now or forever hold your peace, or just reach out to Rich after the talk, which definitely
you can talk to me anytime.
Yeah.
Anybody.
Definitely forward to Carolyn and Taylor, both this presentation and your GitHub, and also any links to that book that you're writing, so that we can all get a copy when it's officially out.
Yeah. All right, I'll post some links in the chat.
Perfect. Yeah, and it looks like that's the end of the Q&A for Rich. Thank you so much, Rich. This was awesome.
You're welcome.
Really very cool to see it live too. It's not just you talking through a package, but showing it.
Yeah, otherwise you wouldn't really know it exists. I mean, you probably believe me, but it's good to see it. It's good to see it.
It's always good to see live coding. And like Raul said in the chat, it's pretty amazing that you built this yourself. So I appreciate you showing us your personal epic project you've built.
Thanks. It was fun sharing it.
Well, great. So with that, again, thank you, Rich, for chatting, and thank you everybody for sticking around. We have a second speaker who has come to speak with us. His name's Ilya. He's also on the call. He's the head of data science at Grid Dynamics. And Ilya, whenever you're ready, we'd love to hear from you.
Hi, everyone. Thanks for joining this webinar. And let me share my screen. And can you see it?
Yeah, I can see your screen.
Perfect. So, and in this session of the webinar, I will be talking about new and emerging techniques that are used in marketing data science and personalization. As a background, let me provide some background on what we are doing at Grid Dynamics. So I'm heading the data science practice there, and we are a data science and engineering services company in general. And we mainly work with large Fortune 1000 or S&P 500 companies, helping them to run different innovative programs, in particular in the space of industrial AI, data science, and helping them to improve their customer intelligence, marketing operations, revenue, supply chain operations, risk management, and so on. And in this talk, I'm going to present some lessons that we learned from doing several projects with this type of clients in the space of media companies, telecom companies, department stores, and so on, related to personalization and related to customer intelligence. And more specifically, after that, I will focus on the question of how we can improve the process of feature engineering for marketing tasks, for marketing modeling, and how we can efficiently create useful semantic representations of customers and products based on transactional data and product data and behavioral data that can help us to build better personalization models and better predict customer behavior and customer intent and customer interest. And I will focus on also to some extent on how it can be implemented. And actually we have open source project called TensorHouse that essentially a collection of different models that are used in enterprise use cases, enterprise operations. And I will show some parts of reference implementations related to that problem in this repository. So first of all, let me start with some basic context on why we're talking about this customer modeling problem and what's wrong, why we're talking about emerging techniques around that, and what's wrong with basic customer modeling techniques that are typically used for personalization problems. So I assume that most of you are familiar with basic techniques that are used for personalization and let's say offer targeting or promotion targeting. One of the most basic things that you can do if you face the problem of how you assign promotions or offers or recommendations to different people who visit the website or who interact with the enterprise through some touch points. You can do what is called lookalike modeling, which is essentially building some sort of a classification model that helps to differentiate between the different customers and quantify their propensities to make a purchase or quantify their propensity to make the purchase from a certain category, a certain product. Essentially, the process starts with some business objective. We can be interested either in acquisition of new customers or making existing customers to make purchases more frequently or buy high quantities of products, or we might be interested in retaining existing customers who have high probability of churn to switching to our competitors or something like that. And based on this objective, we design our predictive model. The process is typically, it can be very straightforward. We take behavioral features of customers like click stream, and we also can take some demographic information. We build some aggregated features based on that in the customer profile, and then based on the business objective, we from these historical samples define some metric that we would like to predict. For example, we can have some customers who converted and who did not convert, and it can be our training label to differentiate between them, or it can be customers who churned or did not churn. And then we train essentially a classification model that can help us to identify customers with high probability of conversion or high probability of churn. And then this model can be used essentially to score any customers with regard to this business objective and identify customers who are good for certain type of marketing activities. For example, customers who have relatively high probability of responding to a certain offer because they're similar to customers who used to respond to similar offers in the past. And then we can use this scores to target these customers with some offers or promotions or something like that. And of course, this basic schema can be extended in multiple ways. We can incorporate lifetime value of customers. We can instead of just quantifying probability of conversion, we can quantify uplift, which is the difference between probability of conversion if we provided an offer or we did not provide an offer, and things like that. But fundamentally, the approach is pretty much the same. And if we are talking about the problem, let's say, of recommendations, how we recommend product to customers, again, the approach is typically quite similar. It's different in terms of algorithm. You know, if you're familiar with techniques like collaborative filtering, typically the problem is framed as matrix factorization. We have multiple items and multiple users, and we have some information about who interacted with each item. And then we are trying to predict values that are missed in this matrix. But this problem can be easily converted to something similar to lookalike modeling. If we do, let's say, one-hot encoding for users and for items, we will again have just a vector of features, and based on that, we are trying to predict our conversion. And this is how we can create a list of products that will be most relevant to a given customer to whom we would like to make these recommendations. So now let's talk about what's wrong with these basic techniques and what are the limitations of these basic techniques. So in general, techniques like lookalike modeling or collaborative filtering, they basically assume that we have some sources of information about customers, like clickstream or some other interaction history, transaction history. And this data ideally should be available in some convenient form, like a relational database or something. And then we do our feature engineering, let's say in a manual way, define our training label, and then predict this label and build a model that is able to predict this label. But there are several problems with this. First one is that in many applications and many situations, data is not readily available in this nice relational form or something, but it can be available only in the form of, let's say, application logs or other semi-structured or non-structured data. And it's typically a big problem how we can do feature engineering based on application logs or something, because these logs typically are not documented well and they change frequently and so on. So people who are doing this feature engineering, they typically spend a lot of time trying to understand the semantics of logs and how different records, different events are related to each other to produce meaningful features and so on. And even more important problem is that if we are doing these aggregated features like frequency of purchases, amount of purchases, the information about temporal relationships between different events in the customer history can be lost, because we aggregate individual events into some summaries, into some features. The second group of problems related to the fact that not all data can be represented in this simple format at all. For example, we can have product descriptions available as text, we can have product images, we can have graphs of interactions between customers, and generally impossible to do manual feature engineering based on this data, but at the same time, this data can be very useful for many practical purposes. For example, if we, as you know, many recommender systems, they are prone to a cold start problem if we do not have any interaction data for new products or new customers, and this problem can be alleviated by incorporating, for example, product images and making recommendations based on visual similarity between images, and we need to handle it somehow, and typically it's not easy to combine behavioral models with content-based models, or at least in traditional systems it is done in quite awkward way using some heuristics or weight mixing. And finally, the third group of problems is related to the fact that in general, if we are doing optimization of marketing operations, we are interested not just in optimizing one single outcome, or predicting one single outcome like conversion or churn, but we're interested in optimizing the whole sequence of interactions with customers over a long period of time, like sequences of offers. And in other words, we're interested in strategic optimization rather than myopic optimization of customer interactions. And this problem, it can be addressed to some extent depending on how we design the training label, but in general, simple techniques that look like modeling, they do not provide efficient framework for doing this strategic optimization. And what we see across the industry and what we use in our projects is that some of these problems, they can be alleviated using some relatively advanced techniques comparing to basic collaborative filtering or lookalike modeling. So first of all, the problem of how we deal with application logs, unstructured data, and event sequences is that we can replace manual feature engineering with sequential input models that are able to consume sequences of events directly, and this simplifies the feature engineering process significantly because we do not need to do this manual aggregation and invent some aggregation schemas. And we also can employ unsupervised learning techniques to learn good embeddings out of behavioral customer data. To deal with the second problem, which is incorporation of textual data, images, information like calls, transcripts, and so on, we can actually replace traditional techniques for collaborative filtering, which are typically some sort of matrix factorization, with more generic neural networks, for example, as it's shown here. If you think about collaborative filtering, in general, the process of factorizing user content interaction metrics can be think of as finding embeddings for dense embeddings for users and for content. And this is what matrix factorization effectively does, right? And then we create our recommendations by computing distances between these dense embeddings to score products according to their relevance to a given customer based on the purchase history. But the same task of computing these embeddings can be actually framed as a process of training a neural network. We can achieve essentially, we can learn absolutely the same embeddings, not through doing algebraic matrix factorization, but through learning these embeddings in standard like gradient based way through training a neural network with some layers that will represent user and content embeddings. But the advantage of this, it does not make sense to do it strictly as a replacement of algebraic techniques, but it makes sense to do it once we incorporate additional information like product images or textual descriptions or customer reviews into the process, which can be naturally done by extending this neural network with some additional layers and some additional inputs. And it also allows us to model more complex interactions between these embeddings instead of just doing a vector product. We can have multiple layers to model more complex interactions, more complex interaction functions between these embeddings. And finally, for the problem of multi-step, multi-stage optimization of our marketing actions, we can employ some reinforcement learning techniques. We can naturally represent interactions with customers as a Markov decision process and optimize our interactions through several steps with a goal to achieve maximum lifetime value, achieve maximum ROI of our campaigns, as opposed to optimizing just a single outcome. And in the next slide in this talk, I will focus mainly on this first problem of how we can optimize. How we can improve the feature engineering process for customer behavioral data, and how we can employ some techniques from NLP area to do it very efficiently. And I will show some examples in the next slides on that. So first of all, let's note that one of the most simple things that we can do to incorporate individual events as opposed to do manual feature engineering and producing aggregated features, we can use sequential input models like LSTMs to consume events vectors directly, vectors that represents individual events like clicks and some information associated with clicks, like page IDs and so on. And then we can process the entire customer journey, which is a sequence of these event vectors. And this way, we can train this model just like any any other regression or classification model to predict some event of interest like conversion or churn. And in our experience, this is actually a great replacement for traditional lookalike modeling, because it allows to efficiently make forecasts even based on short event sequences. This way we can predict potential outcomes like customer churn just based on the first few events, which is generally quite challenging with aggregated features. And it also simplifies feature design, because we don't need to do manual feature aggregation. We just need to make these feature vectors for individual events, which is generally a simpler problem as opposed to representing the entire customer journey as an aggregated feature vector. But we can actually go beyond that and recognize that we can use actually NLP models quite naturally for this type of problems. For example, let's say we have some information about interactions with customers, like history of purchases, which is a collection of different orders, and each order can be represented as a collection, as a sequence of product IDs. And in that case, we can actually directly apply some NLP techniques like word-to-vec or dog-to-vec, because in our case, each order can be represented as essentially as a sentence, and each product ID will be a word in this sentence. And then we can apply, let's say, techniques like word-to-vec to learn some useful embeddings that will be roughly aligned with some semantic information about the product, just like we can learn embeddings for words in sentence in regular application of word-to-vec. So, for example, in this illustration, you can see that an example that we took transaction history for a grocery store, and we represented customer purchases this way, and we learned embeddings. And if we plot this two-dimensional projection of these embeddings and color coded with actual departments to which these products belong, then we can see that this embedding is actually aligned with these departments to some extent. Not perfectly, and actually there is no goal to be perfectly aligned, but we can see that there is some correlation, although the model, it knows nothing about these department labels. It just analyzes these sequences of orders and sequences of products within orders. And actually, model is able to learn these representations quite efficiently. So here you can see how these embeddings progress as we increase the maximum order size that we analyze. If we just take like individual orders, then we are not able to learn meaningful semantic representations. But it's enough if we truncate orders to just 2 or 3 or 4 products in this order, then it is generally enough to learn semantic representations that are able to recognize to which department product typically belongs to. And then we can do it strictly based on this behavioral information like transaction history, but we also can naturally admix content information into this process. For example, if we have product attributes, like in case of department store, it can be color or size or brand of different products, then we can represent each order not as a sequence of product IDs, but as a sequence of these attribute IDs, and again apply word-to-vec or dog-to-vec techniques to learn embeddings for different attributes. And this way we are able to quite easily and naturally combine behavioral data with content data. And then one advantage of this technique and the beauty of this technique is that we can do some algebra around these embeddings, just like we can do it for in NLP world. For example, if we have attribute embeddings, then we can, for example, compute new embeddings for new products for which we do not have transactional data yet, and essentially assemble these product embeddings based on attributes embeddings, and then these embeddings can be used in downstream recommendation models or something to alleviate the cold start problem. And then if we have product embeddings, we can also compute distances between the products, and it can be used to build essentially a recommender system if we can do so. And if we aggregate product embeddings into session embeddings, for example, based on all products that were browsed by customer within the current web session, then we can personalize customer experience based on these session embeddings. For example, we can recognize situations when customer is generally interested in buying several products at the same time, like let's say shoes and t-shirt, as opposed to a customer who visiting the web store with intent to buy just a single product. And finally, we can aggregate product embeddings into customer embeddings based on customer purchase history. And then these embeddings can be used in downstream predictive models like lifetime value models, or in other applications that require, for example, to estimate willingness to pay of a customer and other metrics that can be used to optimize customer experience or optimize pricing or other aspects of customer experience. But at the same time, we can learn customer embeddings directly using techniques like doc2vec. In that case, we will not deal just with individual orders, but we can represent each customer or each user as a collection of sentences, where each sentence corresponds to an order, and each order in turn will be represented as a collection of product IDs. And then we can learn customer embeddings directly using doc2vec, which is generally, in our experience, it's more efficient than just aggregating individual product embeddings into customer embeddings. Yep, and as an example, here you can see again, this example with transactional histories from a supermarket store of how customer embeddings can be used to do customer analytics and customer segmentation, and how the whole thing can be used to simplify feature engineering. For example, if we in this example, we took transactional histories for customers and did some basic feature engineering, essentially represented different customers in terms of departments they purchase from in the store, like categories, and share of wallet of these different categories in their purchasing histories. And it generally is not sufficient to learn meaningful customer segments. As you can see here, we are not getting good separation based on these features, and it means that we need to invest more into development of good features before we can run standard techniques like k-means based on this space. But at the same time, if we just pass through our transaction histories through doc2vec, then and then cluster these embeddings, then we are able to learn good semantic representations based on that. And let me show you a part of the actual implementation of that, so you can go to GitHub and study it in more details if you're interested in that. But basically, here, one of the observations is that if we take this transaction history for different customers and categorize them based on their embeddings produced this way using doc2vec, then actually these embeddings, it turns out that in this case, these embeddings are not aligned with departments, so there is no good separation in that terms. For example, we see that all like all clusters, they are essentially the same in terms of frequency of purchasing from different categories, different departments. So it tells us pretty much nothing about differences between these clusters and their usefulness. But at the same time, if we start to look at the examples of specific customer purchasing histories in these different clusters, we can actually figure out that in one of the clusters, people tend to buy mainly organic products, and in general, they tend to buy healthy food. Meanwhile, in another department, people tend to buy not that healthy food, and in general, they are not. They have no bias towards like low-calorie products or organic products. And this is helpful, and this is actually in many situations that can be even more helpful than good alignment with the actual department labels, which we have as a ground truth. And actually, there is no goal to learn these labels back from analysis of the transaction history. And we can actually continue to apply more and more techniques like that to make the process even more efficient. For example, one of the additional techniques that we used for one of the projects is that we can actually try to learn these representations directly based on the logs, like server logs. For example, if we have a server log in the format that we have a timestamp, we have some event name, and then a set of attributes and their values, which is quite typical for application logs. Then we can just mechanically concatenate event name with attribute, the value like that, and produce this representation of user ID as a collection, as a sequence of these tokens, right? So we do not even need to understand the semantics of that. We just mechanically do this concatenation and convert raw logs into this representation, and then we can apply again techniques for embedding learnings like dog-to-vec or word-to-vec to learn good embedding vectors, and then these vectors can be consumed by downstream classification or regression models to estimate, let's say, customer lifetime values or estimate propensities to different outcomes, which can simplify feature engineering process, of course, very significantly. And finally, the last technique that I wanted to tell about is that we can actually combine this unsupervised learning, which is good, but it does not provide any guarantees in the sense that we just learn in some embeddings that not necessarily aligned with our business objectives, like probabilities of conversion or probabilities of churn. We can combine it with some supervised learning. And the way it can be done, we can iteratively train this unsupervised model and some supervised model that predicts this metrics like conversions or churn in parallel, and just copy embeddings from, let's say, word-to-vec model to this predictive model on each iteration. So we make one iteration of the unsupervised learning here, then copy embeddings to supervised model, train it, make one epoch of training of the supervised model, and copy back these embeddings to word-to-vec and repeat the process. And this way, we kind of align this semantic space of embeddings produced by the word-to-vec model with the space that is has some guarantees in the sense of the predictive power of these embeddings for our business problems. Yeah, and these techniques can be mixed in different combinations depending on the application. So again, you can take a closer look at the GitHub repository at this set of models or some other interesting models that we use for different enterprise use cases. So that's pretty much it. Thank you.
Awesome. Thank you so much, Ilya. And once again, for those in the chat, feel free to ask any questions you have about the presentation just on the Q&A section, and then we can get to them as they come. Yeah, Ilya, I actually had a question for you. I'm very interested because I think a lot of the methods you mentioned are really interesting and clearly are very powerful. I know from working with like LSTMs and other supervised models, they are quite data hungry. A lot of these doc2vec things require repeat purchases, things like that. Is there a minimum amount of data you'd need for you to view these sorts of emerging technologies as viable for your company?
Well, I would say if we are talking about these particular applications like customer intelligence, typically data is not a limitation, because if you do it, for example, for e-commerce company or for some retail company or something like that, then you typically have quite extensive transaction history. So with at least tens of thousands of events or tens of thousands of transactions, and generally more than enough to do this embedded learning and pretty much all the things that I talked about. So it's typically it's not a limitation. And one of the surprising things actually is that if we are trying to apply techniques like LSTM, for example, to predict customer behavior, the surprising thing is that it can be done quite efficiently, even if you have just a few events on average in customer profile. Generally, like 5-6 events is actually more than enough to train LSTM model this way. So when we started to experiment with these techniques, our expectation was that it probably will work only if we have like tens or even hundreds of different events in the histories, but it's not the case. It can be applicable to very short interaction histories.
That's really cool. I did not know that you could train an LSTM with limited data. That's great to know. So maybe while we wait for other questions, I can ask a second question. You mentioned a lot of different. First, please link to us the GitHub about all this stuff so we can look at it more in depth. But you mentioned a lot of different techniques in this talk. Which one are you most excited about and believe has the best chance of really catching on and becoming mainstream across all e-commerce customer data science teams to be using?
Well, actually, it's I think all pretty much, actually all these techniques, they have, I think, very good potential, and actually many of them are becoming the mainstream. For example, if we look at these 3 problems, and this, of course, not the complete set of problems that industry facing, then, these deep recommenders, I think they are already pretty much mainstream, and if currently companies are looking to build or rebuild their recommender systems, they most likely, in most cases, they do something like that as opposed to just using some traditional techniques like basic collaborative filtering. Also, I think there are a lot of interest across the industry in reinforcement learning, and it's not only in the context of marketing operations, it's also in the context of price optimization, in the context of supply chain optimization, because actually pretty much all or very many enterprise problems, they can be represented as a markup decision process. For example, in case of inventory management, you also will have different states of inventory, and you make some decisions which products to reorder or at which point of time and how many you need to replenish and so on. And it can be represented this way again, and you can apply generic deep reinforcement learning techniques to to solve these problems. And actually, even in the repository that I've shown, we have some reference models that are able, you see here some basic demonstrations of how pricing schedule can be optimized this way, or how some simplistic supply chain environment can be optimized this way. And unfortunately, it's not an easy problem, and it's very difficult to scale it to real enterprise scale, like with thousands or even millions of different products and millions of customers. But there are a lot of interests, I think, across the industry. And actually, many large technology companies like Facebook, Google, they invest a lot into reinforcement learning techniques in the context of enterprise operations specifically. Of course, they invest a lot in the context of like pure research, like playing different video games and so on, but also there are a lot of research in the context of enterprise operations.
Awesome, thank you for sharing. And I see there's a question for you in the chat. Can you see the question, Ilya?
Yep. So one of the questions is how important the data quality for learning embeddings comparing to aggregated features. I would say that actually the requirements for data quality are actually lower for these techniques because in many cases it's possible just to, as I mentioned, it's possible to use just raw logs with all the noises in this data to learn reasonably good embeddings. I mean, reasonably good, I mean that they are comparable to aggregated features in their predictive power. Basically, what you can do, you can learn these embeddings and replace aggregated features with this embedding vector, and then train some downstream model based on these embeddings, and the accuracy of prediction, it can be comparable to aggregated features. Or you can augment aggregated features of these embeddings, and in that case, typically you will get even better model comparing to just aggregated features or just embeddings. But in general, the data quality it will not be an issue, and partly because NLP models, they are designed to work with quite noisy data like natural texts, and it's very well applicable to this transactional data. And another question, if I can send a link to the notebook. Yes, of course. And there is another question. Where can I read more and see the presentation? So the presentation, I think, will be shared after this this webinar, and we actually have some articles on this topic in our corporate blog, both on this particular topic and many other topics related to emerging techniques like that. And of course, there are quite many articles published across the industry on this topic. So again, in this repository in TensorHouse, if you go to the GitHub, there is let me share screen back. So there is a list of resources, a list of articles, a list of papers here by different areas. So we maintain it it's mainly papers that are published by industry practitioners and large companies like Microsoft or Facebook and so on, regarding new techniques and AI techniques in customer intelligence, in price management, in inventory and supply chain. So you can check it out. And the second part of this question is how to gain meaningful, how many orders do we need to gain meaningful insights using these techniques? So as I mentioned previously, typically not too much. So it's several thousands, I would say at least tens of thousands. But in these applications, it's typically not a problem if you're trying to apply it to in some B2C environment like e-commerce or something. You typically would have that many orders available for analysis. And the next question is, how do you recommend translating learned features from matrix factorization techniques into interpretable features when your users are less technical marketing team? One possible way to do it is to do clustering in this embedding space. So if you learn some embeddings using any of these techniques, either LSTM or matrix factorization or whatever, then you obtain this semantic space for both users and for products. And it's typically a relatively high dimensional space. You typically would have like tens of different dimensions. And then you can do clustering in this space and do a projection to two-dimensional space as I showed. And then do analysis in this space, essentially explore these different clusters or different groups of customers and find some semantic representation, find some interpretation of these embeddings that can be explained just in plain language to the business users. And actually it's also useful for many marketing purposes. For example, you can define some typical personas or customer segments that can be naturally interpreted, and then it can be used for marketing operations. For example, these marketing folks, they can decide to run certain campaigns for specific personas derived this way. And this is just one technique. There are, of course, some other ways of interpreting it. I don't think that we used it on some of our projects, but there are some articles that describe how you can, for example, take internal state of LSTMs and essentially analyze the dynamics of how this state changes over time through customer journey. And every state, the LSTM, it can be, in some cases, it can be interpreted and can have some semantic meaning that characterizes a certain aspect of customer behavior. And then you can see how it evolves over time and see, for example, that a certain element of this state vector, for example, can grow. If it grows over time, then it is an indication that a customer will churn eventually, things like that. And it also can be visualized in a relatively simple way.
Awesome. Thank you for answering those questions. Maybe we'll wait and see if there's one more, but I think that'll be the end of the Q&A session. Let's give people a minute to think over. All right, so I'm gonna assume that is the end of Q&A and the end of the second talk. Thank you, Ilya, so much for speaking for marketing data science. And again, thank you so much to Rich also for your presentation on Point Blank. I think both these talks were amazing. If you are still in the chat and you want to rewatch these, Taylor and Carolyn will post them. I also wanted to give a shout out to them. They do an amazing job month after month setting this up, even when they have to do everything fully digitally. And I know how hard that is. Makes my job much easier as host. But yeah, thank you so much for attending, everyone in the audience. And thank you so much to our speakers, Rich and Ilya. And we'll send you any follow-ups after this. But I hope everyone has a great Wednesday.